Okay, so now based on this, people, we want to define the derivative, right? And what does that derivative look like? Well, okay, I'm going to give you a few things. Firstly, you all know what's a tangent line. But firstly, I'm going to give you the derivative. I'm not going to make it too specific now. I'm going to make it specific later on. But the derivative is evaluated at a specific point. So when we talk about the derivative, it's basically the gradient of the tangent line at a specific point. Okay? Now if we define this mathematically, we'll say the derivative at x1, y1 is actually the tangent, the gradient of the tangent of the line at x1, y1, etc. But I'm just going to say it's the gradient of the tangent at a specific point. Okay? And then I'm going to give you guys a trick, and I'm going to tell you where all of this comes from, right? Gradient of the tangent at this specific point. That's the derivative. Okay. And now, this is where we start talking about what? Calculus. This is where we're talking about calculus. Because we're now interested in the gradient at a what? At a specific point. We're interested in the gradient at a specific point. Okay. Now guys, the formula for the gradient, I will do notation in another lesson. But for now, I'm just going to say, if the function is f of x, then the gradient at a specific x coordinate is denoted f prime of x. And as you know, that is equal to the limit as h approaches 0, right, of f of x plus h minus what? F of x all over h. Write that down now. Make a note. Put it up big. Say that's the derivative. Denoted f prime of x. Now guys, at this point in time, we've now defined formally the derivative. What I'm going to do next is actually give you a shortcut for the derivative. We're going to look at something called the power rule.